Hi guys, so today we're going to look at some more key characteristics of a graph. As you may recall from algebra, we're going to go over x-intercepts and y-intercepts. So an x-intercept is when y equals to 0. They are the points on the x-axis because any point on the x-axis, the y is 0. They're also the values that you solve for when you solve for zeros, such as factoring and solving for x. Those are the x-intercepts that you're solving for. The y-intercept are points on the y-axis, and any points on the y-axis, you'll notice that the x value is going to be 0. So to find the y-intercept algebraically, we can always set the x to 0 and find the y-intercepts. So I'm going to have this rational function written out in a better form. Sorry about that. So given 2x minus 1 over x, I'm going to start off just by what we went over, the x-intercept and the y-intercept. So to find the x-intercept, I'm going to change the y values to 0. F of x is another way to say y, so 0 equals 2x minus 1 over x. So the goal is to solve. I am going to get rid of this fraction by multiplying both sides by x. And from here, 0 equals 2x minus 1. So my goal is to isolate x. I'm going to add 1 to both sides and then divide both sides by 2. So x equals to 1/2. So one of the points on the graph is 1/2 0, because remember the x-intercepts, the y value is 0. The x-intercepts are the values on the x-axis. So I'm just going to make a point there. And to find the y-intercept, I'm going to go up here, and I'm going to change all of the x values into 0, because remember for the y-intercept, x is 0. So this will be 2 times 0 minus 1 over 0, which, as most of you already know, you cannot have a 0 denominator. So that means that there is no y-intercept. So there are no values on the x-axis. So how am I supposed to sketch this with 1 point? So we're going to use all of the other key characteristics we know about. For instance, vertical asymptotes. So as you know, a vertical asymptote are the zeros of the denominator. So to find the vertical asymptote, I am going to just set my denominator equal to 0. And if I set my denominator equal to 0, it just says x equals to 0, which means I don't have to solve for x, it's already there, but there will be a vertical line at x equals to 0. So there's my asymptote. And then from there, we're going to find the horizontal asymptote. Now, keep in mind those 3 rules or 3 conditions. In this case, the numerator's degree is 1, the denominator's degree is 1. So if n equals to m, then y equals to a over b, which is 2, over 1, which is just 2. That means at where y equals to 2, I am going to make a horizontal asymptote. So what about the rest of the points? You go back to basics in this point. You would make an XY table. And keep in mind, yes, we love fractions because that's when we solve. We want to keep everything in fractions. But when you're dealing with a graph, I encourage you just to change everything into decimal form just to make it a little bit easier. I'm just picking some x values at this point from here. And if you were to plug it in, so I'm not going to do the work for you to plug it in. You guys already know what to do here. 2 times -4 is -8. -8 minus 1 is -9. And -9 over -4, which that would be 2.25. So given the x values, I'm just going to plug them in and get the y values. Again, decimals are just easier when it comes to the graph itself. So at -4, you have a point at 2.25. At -1, you have a point at 3. 1/4, there is a point at -2. And at 4, you have a point at 175. So if you look, you already know with these asymptotes that when I connect the dots, I'm going to get closer and closer to the asymptote, but never actually touch it. So it approaches, but never actually touches. Same deal here. If I connect the dots, which that's supposed to touch, by the way, you can keep going towards the asymptote where it approach, but never touch. And there's your sketch. All right, guys, I hope this helps.